Good afternoon, students. Today, with the continuation of the last lecture, I will explain you the today topics of discussion is your Vhdl data types. Okay, brief introduction I had already given to you in the previous lecture, but today we will do this concept in detail. So, what are the various types of your VHDL data types? This is the diagram for the VHDL data types. As you can see, there are your first, second, third, and fourth. Means there are actually four. There are four types of the four data types in VHDL. First is scalar, as you can see on the blackboard. First is your scalar. Second is your floating. Third is your composite and first is your scalar, first is your scalar, second is your composite, then third is your assess, and fourth one is your file. Now further scalar is further divided into four parts. One is your enumerated, that is your enumerated, then is your physical, then integer, and then last is your floating. Similarly, composite having the further two types. One is your array and second is your record. So these were all the VHDL data types, and I will discuss each one of them in detail with you in today's lecture. Now, going further ahead, firstly I will discuss which means what is the data types actually. Actually, you know that VHDL is a strongly typed language. As we know that it is a strongly typed language, and the type of data object actually defines the set of values the object can assume, or as well as set of operations that can be performed on these values. There are also some certain predefined types in the your VHDL language and operations which are predefined, and that can be performed on these data objects. And these actually contained in a package, means we are getting predefined your data type in a package that is called as your standard. That is called as your that package will be known as your standard. And the new types we can also user can also can declare in VHDL new types, and the type declaration and also the set of operation which can be performed or defined by writing the functions and that return some values of that new type. So various data types which are available in VHDL are shown in the diagram. As you can see, there are four broad categories of your data types. One is your scalar, second is your composite, third is your assess, and fourth one is your file. Now, scalar is again categorized into four different types. First is enumerated, that is enumeration types. Second is your integer type, as you can see on the blackboard. Third is your physical type, and fourth one is your floating type. Also, along with this, also composite types, data type are also categorized into two types. One is your array type, and second is your record type. Actually, the assess types are equivalent to, now further assess types are equivalent to the pointers. As you know that we are using the pointers in C language, and this is similar to that assess type. So assess type is just like a pointers which are used in other languages also. And last is your file. File is used for storing the data, as I have already discussed with you in the data your in the previous lecture also. That is the data objects. So uh, finally the file type actually give the designer or user the ability to declare the file objects with designer defined. Here we can, that was the predefined, data object which is used, that was the file, but this is the actually user defined file type. So here the fourth one, your data type is your file type, and this is this is your designer defined file type, or you can say user defined file type. Now come on to the further. I will firstly explain the subtype. Subtype. Okay. So before further going into the detail, I will explain you the subtype. Subtype. Okay. Subtype is actually, as you may know, that this is the actually nested form of type, that is your subtype. Okay. So it will be understood by some examples. I will write the example. Subtype, it should be in the bold. Subtype. Then subtype, this is the format. This is the format in which we are writing this. Subtype, then subtype name should be there. Subtype name, or you can say format or syntax. This is the syntax or format to write the subtype. Okay. So subtype in bolded, subtype name. Then is your is your keyword. The keyword it should be bold. Then base type. Base type. Then range. Range should be in your bold because this is the reserved keyword. Range should be in bold. Then range constraint. Range constraint. Range constraint. I will write it again. Range constraint. Semicolon. It should be in the single line. It should be in the single line. You can write the subtype here. So I am writing it again. Subtype in single line only. Subtype name. Then is here is base type and the range. Then range hyphen constraint semicolon. Okay, it should be all should be in your same line. This is the syntax. So here subtype is in bold, is also in bold, and the range word is also in bold. Now I will explain you further. Firstly, I have written the syntax of format for this. Now some of the examples, then I will explain these more. So subtype, it should be bold because it's a keyword. Subtype my underscore logic is the keyword std underscore logic. Range, it should be bold. Range, it should be bold. Then single quote 0 to single quote z. Single quote z. And then is here semicolon. Now next is here. Next example is type data underscore word. Type should be your bold data underscore word is should be highlighted. A range should be highlighted or bold. Then 31 down to, this is also should be bold. This is the keyword, down to 0 semicolon. Now I will show you the next example also further. Firstly, I will discuss this. So this is the format or syntax for the subtype. Okay, here subtype is your keyword, result keyword. It should be in the bold. So then I have to write the subtype name. Then is the keyword that should be in bold in this language. Then base type I have to mention. Then range word is your reserved keyword. Then I have to define the range. So that's why I will use the keyword range. It should be bold. Then range hyphen constraint means the range which is to be used. Semicolon. Now the example is that I have writing the subtype, that is your subtype with keyword starting with the subtype keyword, and the subtype name is my underscore logic is, and the base type is here in the Vhdl I am using is standard underscore logic, and the range, then range it is starting from 0 to capital Z, and 0 is also in the single quote, to capital Z is also in the single quote, and ending with this instruction with the semicolon. So next is here, next type is here. Next is the type which is used is here. Data underscore word is range. These both are reserved keyword. This is also keyword. It is your bolded. So type name is here. This is the type. This is type name is data underscore word. Then is range from 30 down to 0. Down to is also your reserved keyword, and 31 down to 0 means it will count from 31 and then 30, then 29, then 28, then 27, and so on, goes on to the 0. So these were the examples of your subtype. Okay, now I will explain the further examples, more examples on the subtype. I will write it. So next example is here subtype. Next is here subtype. Subtype is subtype which is should be bold. This is the subtype name. My word length is underscore length is data word range 7 down to 0. Okay. Before this, I was written the type data word. I will write it again. The type is here. For that is type data underscore word is range 31 down to 0. 7. It means that our main type is here data word, and it is ranging from 31 down to 0. Here type is range down to should be in bold. But now I have taken the subtype for that. Then the example for the subtype is subtype. The subtype name I have written as my underscore word lamp is, I have taken this subtype from this type. So base type is your data underscore word, and it's ranging from 7 down to 0, semicolon. So this subtype is related to this type. So this is the main type, and this is the subtype which is using this. Means it does not use it from 31 down to 0. It only uses the range from the main type, that is 7 down to 0 only. So this is the example for the subtype. So next example is here type MVN. Main type is here type MVL. Type MVL is start from this U 0 1 Z semicolon. Let us suppose I am taking this main type as MVL. Type name is here MVL, and having these elements is the elements are in this type is 0 U 0 1 Z. Now I will use a subtype in this with the keyword subtype, then small underscore MVL. This is the subtype name. Subtype name is base type name is here MVL. I have to mention the base type. This is the base type. If you will compare this with the syntax, so this will be MVL range. Range means we are using only 0 U to 1. U to 1. It means from these 4 elements, I am using only 3 elements, U, 0 and 1. So this is the subtype for this main type. So these were the some of the examples for that. So now if I will write the first one example again, then it will more clear to you again. So subtype logic is my underscore logic is standard std underscore logic range colon single quote 0 to Z semicolon. This instruction means I am using the subtype name is my underscore logic is of base type is standard underscore logic and ranging from 0 to Z. Actually, in standard underscore logic, in this base type, we have the elements like as U, X, 0, 1, Z, W, L, H, and hyphen, bracket close. And your my logic, but my logic is using these 3 elements only. From 0 to Z, that is 0, 1, and Z. So rest of these elements in the main type is not used. So this is the subtype. Now I will compile this subtype. Actually, a subtype contains a set of values which represents only a subset of the values of a base type. and the condition that determines which values are in the subtype is called the constraint. I have already written in the syntax that is range constraint. That is the constraint specifies actually the subset of values of the subtype. So set of operations belonging to a subtype is same as that associated with the base type. Subtypes are actually useful for range checking and for imposing additional constraints on the types. So these were the some of the examples of your subtype. So as you can see in this my logic, I've already explained with you that this is the your subtype explanation. So this was the explanation for your subtype. So now we know that a subtype need not impose a constraint. In such cases, the subtype simply gives the name to an already existing type. So means if I am writing like this subtype, I've already discussed with you, subtype small underscore MVL is MVL. Then in this case, the small underscore, in this case, the small underscore MVL is a subtype with no constraint. Therefore, it uses the set of values that are same in the type MVL. Means we are using all the values which are defined or elements which are defined in the MVL. So it means that it small underscore MVL type subtype having no constraint. It will use all the elements which are defined in your MVL type. Now next is here I am going to explain scalar type. Now further going, first data type is your scalar. So as you know that scalar data type is further divided into 4 data types. So first one is your scalar data types. So the value in this, the value belonging to these types are actually in ordered. That is, relational operators can be used on these values. In the coming lectures, I will also explain the Vhdl operators. In the case of relational operators means we have to make the relation that is your relational operator means less than, equal to, greater. These all will be under the category of your relational operators. So relational operators can be used on these type of values, and this scalar type is further classified into 4. First is enumeration, second is integer, third is your physical, and fourth one is your floating. Now further moving on to the first scalar data type, that is your enumeration. Okay, enumeration type. For understanding this, firstly I will write the sum of the examples. Then I will explain this in detail. So first example is type MVL is U01Z. Semicolon. Then second type, enumeration type example is type micro. Micro is this type word, is word, this type, this is should be in bold. Load, store, add, comma, serve, then div, semicolon. Now the third enumeration data type example is type color. Type color is red, yellow, green, orange. Red, yellow, green, orange, comma, orange. Now the next is here examples of. So before going further, I will explain you this. So you can see that these are the some of the examples. These are the some of the examples which are used for that. So you can see this is the scalar data type and the enumeration type, first type. I have written the three examples for that. I will explain these examples one by one. Then you will understand the concept of your enumeration data types. So actually the enumeration data type declaration defines a type that has a set of user defined values consisting of your identifiers and character literals. Means you are using the identifiers and character literals also, like U0, UZ, load, store, these all. So we can also use the identifiers also. So actually in the first example, type MVL, where type word or is word should be in the bold. As you can see, MVL in the very first example, this one is in the very first example, MVL is an enumeration type that has the set of ordered values as U0, 1, Z. So these values of enumeration type are called enumeration literals. So these U0, 1, Z, U0, 1, U0, 1, Z, these are called as enumeration literals. Now come on to the second type, that is micro. That is your micro. In this case, in the case of your micro, enumeration literals specified in the type declaration, micro is your load, as you can see in the second example. In the case of your micro, you have the enumeration literals named as your load, store, add, sub, and div. And in the third example, the enumeration literals used for the type name as the enumeration literals used for the time. So in the third case, the enumeration literal used for the color. So enumeration literal used for the color is red, yellow, green, orange. So in the third, your enumeration type is your color, And the literals use, enumeration literal use is red, yellow, green, orange. So these were the some of the examples of your enumeration type. And each identifier or literal in the type has a specific position in the type. Determine the order means U is written first place, 0 is written in the second place, 1 is written in the third place, and Z is in the fourth place. So it is in the ordered way. So each identifier or literal in the type has a specific position in the type determined by the order in which the identifier appears. The first identifier or actually literal has a position number 0, means load is at position 0, or you can say U is at position 0, and so on. Next will be on the position number 1, store is on the position number 1, and so on. And when the relational operators are used on these values, then a value is always less than a value that appears to the right in the order. For example, store is always less than div. Means if I am taking this example, then store is always less than div because its position is 0, its position is 1. So its position is 0. The position for the load is here 0. Then position for the load is 0. Store for the store is 1. Then second for add, third for sub, and fifth for div. So store position is less than your div. So it is true. But if I will write like this, sub is greater than div. Sub is greater than div. Sub. This is on the 0, 1, 2, 3. This is your on the fourth position, and this is on the fifth position. Sorry, 0, 1, 2, 3. This is on the third position. This is on the fourth position. So this will be false because this is on the third position. This is on the fourth position. The relation should be sub should be less than div. It will be right. But if it is greater than, then this will be wrong. The right will be sub less than your div. This is right. This is your true. And then this is your false because it is in the ordered way. So actually this was the explanation for that. Now there are some predefined enumeration types also there in this language. First is your character. First is there are some predefined your enumeration types in your Vhdl are. First one is your character. Some predefined enumeration types in Vhdl. Vhdl is your character. Second is here, these are the predefined. These were the predefined data types. First is your character, then bit boolean, then bit, then boolean, then is your sweaty level, then is your sweaty level, then is your sweaty underscore level, then is your file underscore open kind, file underscore open underscore kind, then file underscore your file underscore open underscore status. Okay, so these were the some of the examples of your VHDL enumeration data type predefined. Now I am going to explain further in detail with the predefined enumeration type which are used in your VHDL. First one is your character, second is bit, third is boolean, then is sweaty level, then is file underscore open underscore kind, and last is your file underscore open underscore status. So values belonging to actually, now I will explain one by one. Values belonging to the type character. It constitutes the 191 characters of ISO 8-bit code character set. And these values are called character literals and always written between the single quotes. And it will always written in the single quote. So these were these under the category of your characters. So I will explain this character type in detail. So in the character type, we have 191, actually 191 characters, 191 characters, and each character in this is your known as your character literals. In this, each character is known as your character literals, and always all the character literals are written in the single quotes like A, C, 0, hyphen, 9. These all are under the your character literals or the character enumeration predefined data type. Now the second one is your bit. Second one is your bit. In the case of bit, we have 0 and 1. So this is the predefined type bit, and it has the literals as 0 and 1. So bit predefined has the literals, two literals, one is 0 and second is 1. Now third is your boolean. In case of boolean, we have only the literals as false and true. Means two literals are always there also in the boolean. One is your false and second is your true. One is your false and second is your true. Now the fourth one, that is sweaty underscore level. So then sweaty underscore level will contain the literals under this predefined enumeration type is note, then is warning. These all are the predefined. Warning, error, failure. These four are the literals used in the sweaty level. Now, in the last, so this type is typically actually used, sweaty underscore level type is basically used in the assertion statements, which will be discussed in the further lectures also. Now come on to the next predefined enumeration type is your file underscore open underscore kind. This is the name, and the literals used for this is read underscore mode. Second is your write underscore mode. Write underscore mode. Third is your status, append mode. 3 mode. Append mode. Append underscore mode. So these are the enumeration literals which can be used in your file underscore open underscore find. Okay. So the next is your file underscore open underscore status. File underscore open underscore status. It will include the enumeration literals under this category is open underscore okay. Then second is status underscore error. Status underscore error. Then third is your status underscore error. Then third is your name underscore error and mode underscore error. Name underscore error, and fourth is your mode underscore error. Mode underscore error. So this is the scalar type data types predefined. So predefined data types are here. So this is the last one. Predefined enumeration type data type is file underscore open underscore status. It will use the 4 enumeration literals as open underscore okay. Second is status underscore error. Third is name underscore error. And last is here mode underscore error. So these were the these file underscore open underscore status and file underscore open underscore kind. This will be operated on your file operations. So this has with this I have completed the explanation for the enumeration data type. Now come on to the second is your integer type. Second type is your integer type. So going further, integer type, as the name suggests that in this we are using the range in the integer form. So I will also explain with the help of examples. Firstly, write the example. Type size is range 0 to 31. Range 0 to 31 semicolon. Second is type word is range 15 down to 0. Semicolon. Third is type data length. Type data length underscore length is range 22 to 200. semicolon. So these were the some of the examples for that. So with this, first example is your size. Type size is range 0 to 31. So with this is the type size. Type size here 31. In this, so this is the integer type. In the integer type, actually, an integer type defines a type whose set of values fall within a specified range. Means we have to specify the range. In the very first example, size is an integer type. First example show size is an integer type that includes the integer value from 0 to 31. Similarly, the second example, word is an integer type that includes the integer values ranging from 15 through 0. That is 15, then 14, then 13, and then goes on decreasing up to 0. And the position of each value of an integer type is the value itself. 0 is at the 0th position, 1 is at the 1st position, and so on. For example, in the type declaration of word, 15s is at the 15th position, and the 4 is at the position number 4, and so on. And the values which are belonging to these integer type are known as your integer literals. Examples of the integer literals are like 0, 253, 0, 253, 6E2, then 54440. Then these all are the values, integer values. Integer is your predefined, your integer type of the language, Vhdl language, and it's ranging from 2 raised to power 31 minus 1 to 2 raised to power, this is from 2 raised to power 31 minus 1 to plus of your 2 raised to power, this is from minus 2 raised to power 31 minus 1 to plus 2 raised to power 31 minus 1. This is the range. This is the range used for that. Okay. So some of the object declarations, some of the object declarations using these types can be also shown with an example. Let us suppose I am writing the example constant. We can use the data object with this is constant type. That is constant name is address, and the size size is here is equal to 15. So this is your integer type. So next object declaration we can use with this type of your data type is signal name is data underscore bus word. So these data objects can be used with your this integer type. But in the previous case, like in enumeration, we can use the signal data object and variable data object with the enumeration data type. So in the enumeration, now I will explain for the enumeration data objects used for the enumeration also. The data object which can be used for the enumeration are, for enumeration data type is your, that is your signal, count, MVL. So we can use signal name count as of your type MVL. And the variable data object can be used with the enumeration ALU. Variable name is ALU, and it can use the value micro. It can use the your data type as micro, which I have already explained with you. Now the third type of your scalar is, with this we have completed two types in detail. I have started the scalar. So scalar is further divided into four: enumeration, physical, integer, floating. So I have covered the two enumeration type, and second is your integer. Now come on to the third. Third one type is your floating type. Third is your floating type. I will also explain this with the help of example. Type RTL underscore voltage is range minus 5.6 to minus 1.6 semicolon. Second example is type real underscore length is a range 0.0 to 21.4 semicolon. And the object used for this type of your floating type is, we can use only variable data object with this. So variable length, real length, range 0.0 to 11.9. Semicolon. Now I will explain this in the detail. Actually, as you have seen in the example, floating point means decimal point value will be taken. So, or you can say real numbers. So a floating point type, this is not floating type, this is floating point type. Floating point type is, the floating point type has a set of values in a given range or real numbers. So these above two are the RTL underscore voltage and real underscore length or the examples for the floating point type. In this you can see the type name is RTL underscore voltage, and the ranging is minus 5.6 to minus 1.6. That is in the real number, decimal number. But integer you should take 0 to 15, not in the decimal. Next is your type real underscore length is range 0.0 to 21.4 semicolon. This is the value is also given in the your floating, that is decimal number, and the values which belong to the floating point type are called floating point literals. And the object declaration, that is the which type of data object can be used with this floating point type data type, that is variable. Variable name is variable variable your variable length colon real underscore length, variable name is length, and the sub variable name is real underscore length, ranging from 0.0 to 11.9. So some of the floating point literals are differ from the integer literals by the presence of dot only, that is the decimal character. Thus 0 is an integer. Otherwise, if I am writing 0, this will be integer. If I will write like this 0.0, this will be your floating. This is your integer literal, integer type literal. This is your floating point type literal. So only the difference is your decimal point. And the another example for the floating point literals can be your 0.0, 0.004 or 31.46 or 18.02. These all are the examples for your floating type literals. So these are the floating type literals. With this, I have completed the third scalar type, that is scalar data type. Now come on to the next one, that is your physical data type. Next is your physical data type. So in case of physical data type, I will explain it with the help of example again. Firstly, I will write this example. Type current is range 0 to 1 0 0 0 0 0 0 0 0 0 means 9 times 0. Then units are NA semicolon means nanoampere, then amps, then UA colon UA is equal to 1000 nanoampere, that is micro amps. Next is your MA. MA is 1000 micro AUA semicolon, that is milli amps. And last one is your A is equal to 1000 MA milliampere is equivalent to your amps. Your amps. And this is your last is your end units semicolon. And units semicolon. Now I will explain this the physical type, and the literals actually used in the physical type are your physical literals. Physical data types are used to represent the physical quantities such as distance, current, time, and so on. I have taken the example on the current. So physical type provides for a base unit, and successive units are then defined in terms of this unit. Like NA, UA, I have written on the blackboard, MA. So smallest unit representable in one base unit, that is the largest, is determined by the range specified in the physical type declaration. I am taking the example for the current ranging from 0 to 9 times 0, that is nano. So unit defines are, so unit defines are NA, UA, MA. UA stands for microampere, NA stands for nanoamperes, MA stands for milliamperes, and A is given for the your amp. And last is your end units because it has converted into amperes. So type definition begins with the statement that declares the name of the type current, and the range is here, as you can see in the example, range is 1 into, or you can say 10 raised to power 9. The first unit declared in the unit section is the base unit, that is your NA. This is the base unit. NA is your base unit. Okay, so in the example, base unit is your NA, that is nano. 10 raised to power 9 is your nano. Okay, so after the base unit is defined, other units we can define in the terms of the base unit or in other units. Like in the UA is defined in the terms of base unit as 1000 base unit. That is 1000 multiplied by 10 raised to power minus 9 will be give you 10 raised to power minus 6. Means nanoampere means 10 raised to power minus 9. If I will multiply this with 10 raised to power 3, this will give you 10 raised to power 6. That will be your micro ampere. If I will multiply your, if I will, so if I will, sorry, it will be your, if I will multiply 1000 into that is 1000 10 raised to power 3 into 10 raised to power 9 minus 9, then it will give you microampere. Similarly, if I want to have the milliampere, then it will be multiplied 1000 into 10 raised to power minus 6. It will give you 10 raised to power minus 6, that is milliampere. And the further is here, if you will multiply 10 raised to power 3 into 10 raised to power minus 3, it will give you 1 ampere. So next unit declaration is your milliampere. Then the unit declaration section is terminated by the N unit clause. More than one unit can be declared in terms of the base unit. Means in MA unit, we can declare it as your 1000 MA or 1 in 10 raised to power minus 6 nanoampere. That is where we can say that the range constraint limits the minimum and maximum values that the physical type can represent in the base units. So the unit identifiers all must be unique within the single type, and it is illegal to have the identifiers with the same name. We can't use this. The literals which are used in the physical type are known as your physical literals, and physical literals are written an integer or the floating point literal followed by the unit name. For example, if I am taking the 10 nanoampere, if I am taking the example as 10 nanoampere, then here as a physical literal, if I am taking this, so only predefined physical type in Vhdl is your physical type is your time. So there are also predefined physical type in Vhdl, that is your physical type is your time. With this I am ending this lecture. In the coming lecture, I will explain the composite data type and access and file. Thank you. We will meet in the next lecture.